So just a couple of announcements, a couple of things to take care of. Um, I really thought that having you submit um, corrections for that partner quiz through Schoology would work slick, and it didn't work at all. So if you do corrections on that quiz, email them to me. Just take a picture and email them to me. Some of them worked, some of them didn't. You can certainly check the grade book and see. I always try to include a comment that at least tells how many points you got for your corrections. So um, if you have questions about it, feel free to stay after class and talk or email or, we'll figure it out. All right. All right. Excellent. So last week of trimester 1, we're going to spend our last day today on optimization and look at a very specific situation with optimization. So we're going to look at some financial examples. And so a few things that are important in finances. One would be a cost function. So we're going to use capital C for cost and little c for average cost, which when you're typing, it's pretty easy to tell. When you're writing, it might be a little more difficult. But if cost is capital C of X, then average cost would be capital C of X divided by X, where X is the number of units that are produced. And then there's this thing called marginal cost, which is the rate of change in cost with respect to X. In other words, marginal cost is the derivative of the cost function. And by the way, I appreciate all of you that have your cameras on. It helps me to pace things out. So thank you. All right. So there is definitely, excuse me, a connection between marginal cost and average cost. And that is, if average cost is at a minimum, then your marginal cost and your average cost will be the same. So if we needed to find the minimum average cost, rather than taking average cost and taking its derivative, which you still could do, and setting the derivative of average cost equal to 0, you can take average cost, set it equal to marginal cost or the derivative of the cost function, and solve for X. And you will get your minimum average cost. All right. Moving on. So if we have a cost function, excuse me. If we have a cost function of 2,600 plus 2x plus 0.001x squared, we want to find the cost, the marginal cost, and the average cost of producing 1,000, 2,000, and 3,000 items. And for some reason in economic examples, they write things in reverse standard form. I don't know why. It drives me nuts, but they will write it with the constant first and then go ascending exponents to the end. That's why they're in economics and not mathematics, I guess. All right, so I'm just going to make a little table. And we're going to have average cost. Oop. We're going to have cost. Average cost. And marginal cost. At 1,000, 2,000, and 3,000 items. And to be honest, I would do this just on the calculator. So I would just there we go. So 2,600 plus 2x plus 0.001x squared. So if I go into my y equals, and then what you can do, excuse me, for average cost, you could just take y1 and divide it by x. And for marginal cost, over here in the math menu, there is this option 8, and derive. And we're going to take the derivative of x, and we're going to take the derivative of y1. Again, this is just an option, and we want the derivative at x equals x. Okay, so what nderive will do is it will find the derivative of any function at a specific x value. So it's nice, but it's not 100% helpful. And that is in the math menu on the TI 83 and the TI 84. So what I can do is then create a table of data, and I can just start at 1,000 and look at 1,000, 2,000, 3,000. Or you could obviously calculate them each. So if I start at 1,000 and go up by 1,000, and then look at my table. And I'm going to change my mode. I set this to round for algebra class. There we go. So the cost for 1,000 units, $5,600, which would be $5.60 per unit. And it would have a rate of change in cost per unit of $4. And then for 2,000 units, the cost would be $10,600, average cost of $5.30, and a rate of change of $6 per unit. And then for 3,000, we would have 17,600, about 5.87 as an average cost, and a rate of change of $8 per unit. I'll give you a chance to jot that down, and then hopefully I'll remember it and I'll jot it down on the notes as well. Actually, I think I can do that while I'm sharing this screen with you. Come on. The only real disadvantage to using a table and calculating that is for the next problem, where we're going to find where average cost is at a minimum. It's always nice to have that derivative and the average cost function in order to do that. And looks like we all got it. We're all ready to go. All right, so at what level will the average cost be a minimum? So again, our average cost, little c, is going to be the 2,600 divided by X. Plus 2 plus 0. Excuse me, 0.01x. And marginal cost be 0 plus 2 plus 0.002x. So finding that minimum, we set the two equal to each other. And if we solve for x, the first thing I would do is subtract 2 from both sides. Get rid of that. And then I would move the 0.001x to the left. So we'd have 2,600 over x equals 0.001x. Multiplying by x on both sides. Multiply by 1,000. And then taking the square root. I think that's right. So to minimize the average cost, we should produce 1,612 units. And we'd have it. Okay. Now, if you look at what we did, and I want to focus on this line right here. Because we said that we're minimizing the average cost. And if I just took the derivative of average cost, what I would get is negative 2,600 over x squared plus 0.001. If I set that equal to 0 and solve for x, I am indeed going to get that equation still. So that's why the derivative being set equal to average cost gives you the minimum, and you don't have to do the derivative of average cost. Okay? No? Fair enough? Close enough? Just doing the algebra to show that. And yes, that last step, I did two things. I added the 2,600 over x squared to both sides and multiplied by x squared to get rid of the variable in the denominator. All right. All right, next. So the other kind of big idea in economics is demand. And so if we have a demand function, that's the cost that we charge per unit that we sell. And that is denoted by P of X. So if we sell X units of some item, that's called our revenue. And it's X, the number of units sold, times the cost per unit, which is P of X. So our revenue is equal to X times P of X. Profit, that's the big thing, is simply our revenue, the money we bring in, minus our costs, minus the money we spend. So profit, capital P. So again, we have one function as little p, one function as capital P, which isn't the best. But capital P of X is equal to capital R of X minus capital C of X. To maximize profit, we can take the derivative, P prime, and that would be where R, P prime would equal R prime minus C prime. And so if we set that equal to 0, our profit is maximized when the marginal profit, when the marginal profit is 0, right? Marginal profit is just the derivative of profit. And that is 0 when marginal revenue is equal to marginal cost, when R prime is equal to C prime. All right. So what will this look like? A store has been selling 200 compact disc players a week when they charge $350 each. A market survey indicates that for each $10 in rebates that are offered to the buyer, the number of sets sold will increase by 20 a week. Find the demand function and the revenue function. How large a rebate should the store offer to maximize its revenue? So if you need to come up with the demand function, which we have in this case, the demand function is going to be the cost, or not the cost, the amount that we charge per unit. In this case, boy, oh boy. In this case, that $350. So I'm going to write it in words, and then I'll put the equation in. So it's the amount charged minus number sold divided by increase in sales times X minus, no, that's not, try this again. Shouldn't be number sold, that should be change in price. And then we'd have X minus, this is where number sold should be, average number sold. So in our example, we initially charge $350. We know that for every $10, excuse me, for every $10 that we lower the price, we will sell 20 more CD players. And at $350, we would sell 200. Excuse me. So if I do a little bit of simplification, so the demand function is going to be negative 1/2 X plus 450. So there's our demand function. That's the first thing we were asked to find. We were then asked to find the revenue function. And revenue is X times the demand function. And then in this case, we were asked to maximize our revenue. So we don't have a special formula to maximize revenue. We just have to take the derivative and set it equal to 0. Take the derivative, set it equal to 0, solve for X. I know that this one's a tough one to solve for X. So take your time, make sure you don't make any mistakes. Because I know I'd probably do it wrong. So our revenue is maximized when we sell 450 items. Okay. I just want to, what we want to find though is the rebate. So what we're going to do is go back to our demand function to see what price we should set at to sell 450 items. So we're going to find the demand function at 450. And so we're taking 450 and subtracting half of it. So our price should be $225. So if our original price was $350, and our new price is going to be $225, we would need to offer a $125 rebate. Questions on that one? There's a lot going on in that problem. So the big idea, or one of the big takeaways from this problem, is actually this demand function that we can use this general setup for any situation. So hint, hint, you'll need it for your homework. All right. Speaking of homework, um, 43B, because we actually did 43A in part of the notes. 44B, because we already did part A as part of the notes. And then 45 and 47 will be like the last example that we did. I know this is probably gonna, break your hearts. We will not have a new assignment on Thursday. So this assignment will be, get this assignment done by Friday, so that I can do grades, kind of an important thing. Make sure you get that AP problem turned in. If you haven't already, it looked like most of you had, which is awesome. And if you're gonna do corrections on that partner quiz, then we'll need to take care of that as well.